Good morning. I welcome you all for a session on pointers in C. In this section, we will have a brief mention towards a pointer variable declaration, its definition, which is more like a pointer initialization, then the various operation on pointers, how to have a call by reference activated in a function using pointers, then using the constant qualifier with pointers, then pointer arithmetic along with pointer expressions, and then the relationship between pointers and arrays, where we have an arrays of pointers declared and defined. Now moving on towards introduction of a pointer. What is a pointer? A pointer is a variable as like any other variable, but the simple difference is it would store addresses rather than values. This is a variable that stores addresses of another variable. To be short, it is powerful, but it is difficult to master. You can simulate call by reference in functions using pointers. There is a close relationship of pointers with arrays and strings. Let us now have a brief glance at pointer variable declaration and initialization of a pointer. What is a pointer variable? It contains memory address as its value. Number 2, normal variables contain specific value which are direct references, whereas pointers hold addresses which are indirect references. Pointers contain address of a variable that has a specific value which is an indirect reference. What is indirection? Indirection is referencing a pointer value. To be short, if we say a variable, say C, it has a value 7 within it. When I have a pointer, this pointer has an address of this variable called C, where I do call this as a pointer, or it is an indirection, or it is a reference. Now, how do I declare pointers and how do I initialize them? You always make use of a symbol asterisk with pointer variables. This asterisk tells you something that the variable that you are going to declare is a pointer. If I say int star x, it means that x is a variable of type integer and it is termed to be an integer pointer. It declares a pointer to an integer. Multiple pointers can be used in a single program, but every pointer has a unique reference. You can declare pointers to any data type. It is always not a mandate that you want to have its type as integer. What is the difference between a variable and a pointer then? A variable takes its type from what it holds. Say for example, if I have C here as a variable, it holds a value called 7, because of which we try to have C declared as an integer. Unlike these variables, pointers take their type from what they point to rather than what they hold within them. If we can believe, every pointer, be it an integer pointer or be it a character pointer or be it a floating point pointer, is always going to hold an address of another variable. We know that addresses are going to be of a particular type. Then does the type of a pointer depend on what it holds, that is the nature of the address that it holds? No. The type of a pointer gets decided by what it points to rather than what it holds. So to be in short, if a pointer points to an integer, then the type of the pointer happens to be an integer pointer. If it points to a floating point number, then it is a floating point pointer. If it points to a character, then it becomes a character pointer. Now let us have a glance at the various pointer operations. We make use of different operators within pointers. The next most commonly used operator within pointers is the ampersand symbol. What is the use of this? It is termed as an address operator. It returns the address of an operand. What do we exactly mean by it returns the address of an operand? Let us have, for example, a small variable declaration, a pointer declaration, a pointer initialization, and then a pointer manipulation. The first line of your program starts like this. it says int y equals 5, which means I try to declare a variable y which is going to hold a value 5 and it is going to be of type integer. Then I try to declare a pointer, that is a y, I try to declare a new pointer yptr of the same type integer. Imagine I have just declared a pointer of type integer. Now I would like to assign this pointer a value. So what is the value that I am going to associate with this one? I say that it is the address of y that gets assigned towards this pointer. What does this actually mean? yptr gets the address of y. For visualization, you can have it as this. This is y. I have yptr, which is pointed towards this one. It gets the address of this one. This is the basic understanding of the entire piece of code. Or to be short, if I am going to store a value 5 in y, which has its address as 600, imagine its address is in terms of 600, then what will be there in yptr? yptr would hold an address called 600 within it. This is what we do exactly mean by having pointers assigned towards variables. The most important operator to be noted over here is the ampersand operator, which means that it gets the address of the operand. Moving on to the next kind of an operator, we often make use with pointers. That operator is termed to be an asterisk operator. How do we programmatically call this? It is known as an indirection or a dereferencing operator. An indirection or a dereferencing operator is an asterisk operator. What does it do? It returns a synonym or alias of what its operand points to. Say for example, star yptr returns y. If you can have a glance at here, I have stored a value 5 inside y. I have declared a pointer. I have made this pointer point to the address of this particular thing, that is, this address is moved into this yptr. So when I say asterisk yptr, it returns y because that is the value that is getting held in this particular address called yptr. Then if I say star yptr equals 7, what it does is it tries to move this value 7 inside y, as a result of which the value of y, which was earlier 5, gets converted into 7. Now this is what we do call as dereferenced pointer. This dereferenced pointer must be L value and it should not be any constants. I hope you understand what I mean by L value and R value. L value stands for the left hand side value and then R value stands for the right hand side. So the dereferenced pointer, that is operand of star, must be an L value and it should not be an R value. Now let us talk about asterisk and ampersand as inverses. That is, one cancels the effect of another. That is, whenever I say star ampersand yptr points to star, that is address of yptr, which means that star into address of yptr, which returns an alias of what operand it points to. Likewise, when I say ampersand star yptr, it always refers to ampersand star of yptr, which is address of y, which returns the address of y, which is yptr. To be short, let us have it written over here. I try to make use of the asterisk and ampersand together. Let us see how it looks like. This is for yptr. We know that yptr is a pointer variable that we had declared, and we are trying to make use of these two operators together. Let us see what happens. This can be written as asterisk along with address of YPTR. What is going to be in this entire thing? It is the address of an YPTR. That is, it becomes something like address of YPTR, which is a pointer. Now, what is this equivalent to? This returns the alias of an operand. This returns an alias of operand what it points to. So, this directly becomes the alias. Now, moving on to the other way. What would happen if I make use of these two in another different way? That is, I say that ampersand followed by asterisk. What will happen here? This is similar to having address of the value present in YPTR, which is more or less equivalent to what is star YPTR. We have just a while ago we have mentioned that star YPTR is simply Y. So, what is address of Y? What is address of Y? It is again stored in YPTR, which means that when these two are together, one nullifies the other, which leaves with the remaining operand alone. That is why we do call these as inverses of each other. So, these are the two most important operators that we associate with pointers.